What's up, kids? It's Mr. Berner. Welcome to Mr. Berner's Science Boot Camp. We're going to learn a little bit about Newton's laws. I'm going to get a little shredded, and your minds are going to get a little ripped with knowledge. Let's do it. All right, follow me. Let's get started on Newton's first law. So again, Newton's first law is an object at rest tends to stay at rest unless acted on by an outside force. And an object in motion tends to stay in motion unless acted on by an outside force. Let's test it out. Okay. Let's take a look at this object, for example. It seems at rest. It doesn't seem to be moving, but let's just check and make sure. Yeah, it looks at rest. All right, let's act on it with an outside force. I am that outside force in this case. And again, now that this object's in motion, it's gonna want to tend to stay in motion. Oh yeah, pumping out content. All right, let's test out another example. Right here, we have 3 weights stacked. We have some papers located in between. Cameraman, can you come get a shot of this? Let's see. We got a paper coming out this end. We got a paper coming out this end. Let's see. Are these objects going to stay in place when I remove the paper? 3, 2, 1. Newton's first law. All right.
So as you can see in the demonstration, the weight will stay on the ground until picked up or moved by an outside force, that being my arm. Once the weight is being lifted, I will continue to lift it until it is acted on by an outside force, which is again me losing my strength and becoming weak and having to put the weight down.
Okay, y'all, so here's a visual of Newton's first law. Again, objects at rest tend to stay at rest unless acted on by an outside force. Objects in motion tend to stay in motion unless acted on by an outside force. So again, when you saw me move the paper from the weights stayed in place because of Newton's first law. The weights were at rest and they tended to want to stay at rest. All right, on to Newton's second law. So Newton's second law basically states that force equals mass times acceleration. So as I continue to increase the mass on this barbell by adding weights, it'll continue to get heavier, and I'll need to exert more force to get the barbell back up. So again, we all know that heavier things require more power for lifting. It's almost like it's common sense. All right, let's start out with an easy 50 pounds. Come on, class, you know Mr. Berner's got this one. Oh yeah. You can cut it. So we saw the amount of force that I had to exert for a 50-pound barbell wasn't too much. But again, it's now 50 pounds heavier with 2 more plates. Let's see if old man Mr. Berner can get this weight back up. Y'all know that was easy. It's even heavier now. I'm gonna have to exert even more force to get this weight back up. But you already know I got this. Baby! Can Mr. Berner be stopped? Alrighty. Now let's do our final test for Newton's second law. Can old man Mr. Berner get this weight back up? Let's find out. Oh dear, oh my, oh geez. Yes!
Tried to celebrate my triumphant lift with my loving cat Pinky, but she ran off, no worries. As you can see, as I continued to stack more weights, the barbell got heavier and I had to exert even more force each time to get the barbell back up. That's basically Newton's second law. As mass increases, acceleration slows down, or as mass increases, the force required to get something moving increases. That's some science.
Coming at you live with a visual, it's Newton's second law. Again, force equals mass times acceleration.
Okay, so maybe as you can tell, I've had a lot of coffee this morning and I'm really jacked up to teach you Newton's third law. So again, basically Newton's third law states that for every action or force, there's an equal and opposite reaction. Let's test it out.
All right, class, let's test it out. For every action or force, there is an equal and opposite reaction or force. Okay, so as you can see, when I slam into the wall, not only do I exert a force on the wall, but the wall exerts a force back on me, causing me bodily harm. All right, since this is Extreme Science Boot Camp with Mr. Berner, let's try that again with just a little bit more force this time. Whew. So as you can see, the more force I exert on the wall, the more force the wall exerts back on me, and the more damage is done to my arm.
Alrighty, y'all. So again, that'll be Newton's third law. For every force or action, there is an equal and opposite force or reaction. All right.
Well, unfortunately, there's only 3 Newton's laws. There's no 4th one, but again, there should be a law against being this darn cute. Say hey to the kids, Pinky. Meow.
Alrighty, that's going to conclude our lesson on Newton's laws. I hope you students learned a lot, and I hope your brains are just pulsating with knowledge. Alrighty, bye-bye now.